Hey, thanks for watching another video from weldingtipsandtricks.com. This video is a demonstration on two welding machines, a Miller Diversion 180 and a Everlast PowerTig 185 Micro. These two machines are very similar in amperage rating, as well as another thing in that they're simplified machines. They don't have all the knobs and features to confuse you. This is for the market that doesn't want to know all those knobs and things. They just want to weld. So the Diversion is ultra simplified with only a material type and an amperage switch, and the Everlast also adds in AC balance and AC frequency. Not quite as simplified. So what we're going to do is we're going to weld a bunch of different type stuff here on DC and AC. Big chunk of steel just to check how smooth the arc is. And first we'll weld with the Diversion 180. We'll just stack a bunch of beads next to each other, and just to get a feel for both of these. What you hear in the background is the fan on demand on the Miller Diversion. The Miller's got fan on demand. It's kind of loud, but it only kicks on when you get to welding. The Everlast runs all the time. It is running in the background right now. It's a quiet fan, but it doesn't kick off. It runs when you have the machine on. So that's the trade-off there. The two machines are pretty much similar on how they did on that. I couldn't really tell a difference on the smoothness of the arc, and they did just fine on that. It was no surprise. I'm going to weld some 50,000 stainless here, hole fill. Just filling. The common thing is to fill a misdrilled hole and some sheet metal. I am backing this up with a big chunk of solid copper. There's a good tip for you. Just hang on to all the copper you can get, because it comes in really handy for backing up stainless steel when you either don't want to take the time to use argon, or it's just not feasible or not economical. Sometimes just copper backing dead against the back of a hole like this is just as good, or you know, as for the purpose, it's good enough. And what it does is it takes a lot of heat away. It traps a little argon on the backside, and I'll show you the backside in just a minute. This is the Everlast. The first one was the Miller, the hole fill. Both of them are very similar in how they did there. Plenty good low-end characteristics to do 50,000 stainless. There's the front side. There's the back side where it was against the copper. Front side again. Back side. You can see it's pretty shiny, not quite as white as it would be if it was good argon shielding, but you don't always need perfect. Sometimes that would be a heck of a time saver rather than having to purge the back side on that with argon. All right, here's an outside corner joint on 18 gauge. That's roughly 48 thousandths, just regular old carbon steel. That's that fan on demand running in the background again. That booger's a little bit loud for my taste. All right, on the edge weld, on an edge weld, the Miller here, this is running up. The Miller has excellent low-end arc characteristics. I can run a bead on 48 thousandths steel. This is the bottom end. I had the machine amperage, the panel amperage set on probably about 100, but still was able to control it. Not quite as much with the Everlast. The Everlast didn't have quite as good of a low end on the DC, which is kind of surprising, because I think it's actually I think the Diversion is actually rated higher on the low end. All right, here's the aluminum. This is the Everlast run. Everlast actually fared better on the low end on aluminum. Was able to control beads better. This is the Miller. Got a little hot. You can see it nipped it real good where I started. And this is the Everlast. Was able to run a really low amperage bead on the edge of a piece of 16 gauge aluminum. So, you know, one's better in one area, one's better in another. That's not very surprising either. That's generally the way things are. And here we go with the Diversion on some 1/8 inch 11 gauge aluminum. Got a little contamination there to start with. That could be it's set a little high on its default on the AC balance, but also I went and turned the argon up a little bit. Sometimes not quite enough argon will give you the same symptom as not enough cleaning action. In any case, it cleaned up right away here, and a good, smooth, stable AC arc. It appears to be, just guessing, I would say this is its default setting is about 100 hertz on the frequency. And I always recommend, you can weld most anything with 100 hertz if you're going to do a set it and forget it if you do have adjustable AC frequency. That's a good setting to do. Here's the Everlast. It sounds like about 120 hertz maybe. Again, it's a good, smooth, stable arc. No problems there. Good clean puddle. I've got the cleaning action, trying to set the cleaning action similar to what the diversion was here by the width of that frosty band outside the weld. So there's the Miller, got a little contamination to start, but again, once it got going, fine. There's the Everlast. You can see the little pinhole at the beginning on the Everlast. Now here's another tip for you. When you're lighting up on aluminum, wait until you puddle it. Wait for that brown ring outside to completely go away. See, I didn't quite wait for it to go away. I went ahead and melted and added rod, and I got a pinhole. Now we're going to push the limits. We've got a piece of 1/4 inch aluminum plate here and a piece of 1.5 inch solid round stock. Now neither one of these machines is really intended to weld anything this thick. And anybody buying one may not ever need to weld anything this thick, but I'm gonna, just to show the difference, just to kind of push the envelope a little bit. This is the Miller. Now this takes a while. I'm maxed out. Normally, if I had something this thick, knowing I only had 180 amps, I would certainly preheat it and might even position it to where it was in the vertical position up, give me a little bit of edge on it. But that's not what I'm doing today. I'm just trying to push the envelope on both these machines on the low end as well as the high end to see how they fare. So waiting and waiting and waiting, and eventually that thick piece will get enough heat to puddle, and eventually I can join the two, and then heat will conduct once I get the two joined, and then I can proceed with somewhat of a bead here, but not much of one. Not really welding that clean, not really welding that good, not hot enough, not near hot enough, but can join them. That's maxed out at 180 amps, and then we'll do the same thing with the Everlast. You can see that brown area cooking away on the big thick round stock there, that cleaning action doing its stuff. And I'm maxed out here, and I probably should have waited before I ever added rod. Probably should have waited just to heat up. I'm going to direct the heat on the thick piece now and try to hang out there a while until I get a puddle. It's going to take a few seconds. You can see one forming now, barely. You don't always want to max something out to start with either, because all that arc force can give you all kinds of porosity and all kind of rough etching. You just kind of hang out there at a 3/4 amperage until you get some preheat going, and then romp. It's probably a better idea. So looks like I've got somewhat of a puddle going on the big thick 1.5 inch. It's on the upper side, and then I'm going to try to jab the rod in there and get them joined together. There we go. Now the heat will conduct. And it's a slow go, because again, it's 1.5 inch round stock to 1/4 inch thick plate and only 185 amps here, so it's just not hot enough. You got to go slow. You got to go back and forth, almost as if you were brazing to wash a little bit of metal down into the joint. Otherwise, it'll just bridge the gap, and you won't have much penetration at all. And again, if I position this thing vertical uphill, it would help keep that puddle down below the arc. It would help a little bit. It'd be like adding 5 or 10 amps. It wouldn't be like night and day. So that's it. Both of them, that joint was way too thick. So let's compare the torches a little bit. The Everlast came with a 26 torch, the Miller a 17. 26 is rated at 200 amps for air cooled, and a 17 about 150. The Miller has an on-off switch as well as a amperage control on the torch, and comes with a foot pedal. And when you plug the foot pedal in, it bypasses that, so you don't have to worry about doing anything. Just plug the pedal in, and you're using pedal. It's a really small pedal, and has connectors kind of like Ethernet plugs on a computer, sort of like that anyway. And they're just plastic clip-in things, and I don't know if that's good or bad, but it worked. The rest of the connections are all hardwired. I don't understand that, and don't particularly care for it either. I'd like to be able to change torches if I want to, really easily. The Everlast 26 is a big torch. It's a lot bigger than what I would like to use, but it's only got the rocker switch on it. Again, the panel has got AC frequency as well as AC balance on it, so it's not quite as simplified as the Diversion. It's only got amperage and then material type. The pedal does not come with the Everlast as part of the package, and this is probably what you'll get if you order one. I would advise getting a pedal, even if it's that one. I would ask for a better pedal and see what they say. So that's it, comparing those two machines. Next week we're going to add helium and show you what that does. Very surprising also what it does. This is a little preview of what happens when you add enough helium to the mix. This is an 1.5 to 1/2 inch piece of aluminum. Not very big, it's only about 4 or 5 inches in diameter, but I didn't preheat it, and it was very surprising what I could get out of either one of these machines I'll show you a little bit more, talk a little bit more in depth on adding helium and what's involved and the parts you need for doing that, etc. But anyway, that's it for today. Thanks for watching. Visit weldingtipsandtricks.com. By the way, I would be happy to have either one of these machines.